Here I'm looking at the map of the US. So this is historical data, and I'm looking at back, this is 2013, June 3rd, which was Monday. So Monday, not too many people are flying, but you can see out of Moriarty there is 22 people flying, and that's because there is a contest there. So I can drill down to Moriarty now and see who is flying. So again, this is historical information. So now I can zoom in and look at the tracks. So let me point out a few things. So on the main action is in this map page. So the map page here. On the bottom is the timeline. The timeline allows you to navigate through the days, through historical information, as well as through that specific date that you are looking at. So in the middle of the timeline, this white space you can sort of see also indicates when the sunrise was and the sunset, and it shows indication for when there was data for all these competitors. So I can put I can just click in the timeline, put the cursor here, and so now I'm looking at 7 minutes past 3 o'clock, and this is where people were at that point in time. And I actually now have 21 selected, which is Rick Culbertson, or I can select Jim Murray. So this is his track, but let's switch back. So this is where everyone was at that time of the day. And I can click at some other time, see where they were, or I can also just simply drag my mouse through the timeline and basically get animation who was where. So this is really just what happened during the day. What's new in this version is also this play button. So now I can also hit this button. I can place the cursor at any place in the timeline and hit the play button, and it's going to be playing the data. So now currently it's playing at 8 times the speed, and I can increase it, make it like go really fast. So this is what people are doing. And I can click here and go in reverse, but let's go forward. And we can stop playback. Another thing that's new in this version is this barogram, which is just this white box. Well, it's a white box because all these tracks that you're seeing, this is people with spots. And spot satellite messages, they don't have altitude information. So the barogram shows nothing really. But this barogram can be used as a proxy to my timeline, so I can also drag through it and see. It's just another way to set time. So speaking of timeline, so there are 2 buttons. So for example, if I wanted to go to the next day, I can click this button. So I'll click it now. So this is the tracks there next day again, and I can just scrub through, see what people did. And I can zoom in and do all kinds of things that you normally can do with Google Maps. Let me just jump back to the previous day. There is also this new button which gives you a little calendar. So this allows you to jump to any day. I accidentally hit it, so I now jumped to March 12th. So let me jump back. So that allows you to navigate through time within the context of the day and within the calendar, so you can see any historical data. So let me just go back one level up, and I'll go on that specific date. It happened to be Monday, but it was a good day, and I managed to get out of work. So here's one trace out of Boulder, which is actually me flying. So I'll zoom into Boulder, and here's my trace, and they happen to land out on that day. But on this trace you can, I keep hitting buttons, you can see the barogram Basically, because I was flying with InReach, and the InReach satellite device does have altitude information. So it shows me, you can also see this is about 2-minute fixes. Here is a fix that was 11 minutes, so this is when I turned it on, and then towards the end it lost signal for like 36.5 minutes. But so it shows you altitude information, and just as what you would expect on a barogram, and it shows you the terrain elevation below me. And few more things. There are few tabs. So this weather tab allows me now to turn on weather overlays. So these are the weather overlays that are available for this specific location. So I'll just turn it on by I'll turn it on by hitting this checkbox. So here it is. So now if I click on a map, so let me click about in the timeline or in the bar. So if I click here, so I'm looking at 2:25 in the afternoon. So I was about here, and this is what the clouds looked like. So you can see my route from there. I sort of went under these clouds, and if I keep moving, this is going to update. So as I'm moving, and you can sort of see now if I even zoom in. So I'm just zooming in here on this area. So you see how I went under these clouds, but this whole area is now sort of clearing up, and I'm under these little clouds, but there is nothing here. So the day basically died on me, and this gives you sort of lots of insight what was going on in the day. You can change the opacity of those weather overlays, and so this is just a visible cloud layer. There is, for example, aviation weather, which gives you different coloring. So if I zoom in, so again, I'm looking at roughly 4:30 in the afternoon. So this is basically some thunderstorms here, thunderstorms here. So again, you can sort of see everything is dying in this hole. Didn't have enough to climb to jump over the mountains to get back home. That's the weather overlays. So you can turn them on and off. So they are synchronized again. So I can just you see how the day was developed during that day. So it's very useful after the flight to see when you fly to see what was happening. It's very educational. Another thing is there is also a complete Libraker database in here. So what I'm looking here is actually Black Forest Turnpoint list, and which has a bunch of Turnpoints. And this is useful. You can just go to look at the Turnpoint, and so here is Silver Hill. So if I switch to satellite view, it doesn't really look very landable. So that's a bad Turnpoint in the database, it looks like. So it's really good to, if you know where you're going to be flying, to go, especially when you're going in the mountains, use this, check out really the Turnpoints that are in the database, figure out what's landable, what's not. So it's a really safety type of thing. The big new thing in this new version is that in addition with to Spot and InReach tracks, now it allows you to have what they call high-resolution tracks. So Spot basically tracks you at 10-minute intervals, and the InReach allows you to select the track interval. It goes down, I believe, to about a minute. But still, that's pretty rough interval. By eyeballing, you can figure out when a person is in a thermal and when they are gliding. But it's eyeballing, and there is no really good way to automatically analyze that. It's nothing like a full resolution IGC track where you can get really good analysis. You can figure out what person's performance, and you can figure things out. So what's new in this version is now I have my, I'll just zoom out. I have turn off the turn points. So I have my inReach track, but here is my IGC file for that day. So I can actually go now and edit my IGC, this is my inReach track. So the new thing that's in there is I can add the description of the flight, I can select the glider, provide some information, but I can also just simply drag and drop my IGC file. Now, and I'm going to save it, so now I have my, so if I zoom in, so let me just zoom in all the way, so now you can see my thermaling. This thin red line here is basically what inReach showed me. It had like one fix I'll highlight it. It had one fix here and then another fix here. But this is, I mean, you see a lot of stuff that happened here. This is me just trying to scratch out and come back home, but it wasn't working. So, so this is really now a track that was inReach, which is now turned into a high-resolution track by uploading IGC file after the fact. When I did that, one thing that you notice is that barogram is now also looks different. It looks much richer. So it also shows you on the barogram, it shows you thermal and glide segments. So this is unlike any barograms that you've seen ever. So it's, with one glance, you can really see where the thermals are. They are shown in this pink highlight, and the shade of pink indicates how strong of a thermal it was. So if I, let me just zoom out the whole flight. So now if I even just simply hover over a barogram, you can see, so I'm hovering over this glide segment at the bottom in the barogram. So that glide segment corresponds to that glide segment on the map. It's highlighted on the map. So, and here is the thermal behind it. You can see it on the map. And I can just really double click. So here's that thermal. So I just zoomed in. So here is that thermal. And now I can actually, let me actually reduce the playback speed to something reasonable. Now if I play, you can sort of see how I'm climbing there. And in the barogram, I'll just zoom out as this is playing back. So in the barogram, you also see flight analysis. So this segment is 9 minutes 48 seconds. I made 19.6 miles at 120 miles an hour, and my glide was 1/33. This, sorry, I just clicked. So this thermal is stayed in it 5 minutes 16 seconds, climbed 4,000. A little over 4,000 feet, and it was 7.7 knots on average for the thermal. So, and then this segment, I glided at 1/57, almost 21 minutes, made about 43 miles. So you get all of that information. It's really, really nice. So when I put the cursor any place in the timeline or on the barogram, I basically set the time that I'm looking at. And that time is also shown in this time code indicator. If I close that time code indicator, it basically shows me the latest data. So, and that's important when you are viewing actually live data. So if you are viewing live data and put the cursor back in, it's going to stay there showing you that data. You can go and play it back, but basically it's not showing you the new data as it is coming in. Okay, and so next thing that's new that makes really this very nice is this button here. So if I click this button, oops, I missed it. So we get this view. There is a 3D view, so I'm now in the God's view mode. So if I click back someplace on the track, again in that God's view, so here is where I was, so I'm kind of flying, looking at the glider, and I can get closer to the glider, so here is the glider, and look around, look back, and if I just click playback, it's just going to be playing. So I'm looking at behind the glide. There is also, and this is playing now at 15 times the speed. And there is also a pilot's view, so I can switch to that view. So here is, again, this is at 15 times the speed. So this is what I would be seeing from the cockpit at that point of time. And this is playing, let me explain a few other things. So you see all the basic instruments in the glider. So here is your airspeed indicator. So this is basically the airspeed that I was making at that time. The little red bug is the average airspeed for that glide segment, because I'm in the glide segment. So I was making about 85, showing 85 knots indicated on average. So sometimes going a little, above 100, sometimes going slower, but on, just as I was bumping the bumps. But on average, that's what it was. In the middle, there is the variometer. So this is total energy variometer. So the red needle shows the instantaneous reading. The little green triangle bug shows the total for that segment. So here, actually, now I'm in the glide segment. So I'm obviously going down in that glide segment when I. Let me actually quickly jump into the. So here I'm in the next thermal. This is a 10-knot thermal even. So you see, it's indicating the strength of the thermal. This diamond head type of hand is indicated. That's a 30-second TE average. And then finally the altimeter, the three hands are showing the pressure altitude. And the number readout here, that's actually GPS altitude. So that's why the hands and the numbers are different. So GPS altitude typically indicates higher reading. And then the little triangle bug, that's the terrain elevation below me. And then this, in this case, red arc, that's actually showing the altitude differential for this segment. So since I'm currently gliding, you can see, so here's the glide segment. Actually, now I'm in a thermal. So in that thermal, I climbed from whatever, 13.7 roughly to 15.5 thousand feet. So it's really good way to visualize what your range on each segment is and what your working band is. You can also, of course, see all of that on the barogram, but it's actually really nice to see it here. The next thing down is this flight analysis. So this is analysis for my whole flight. The triangle for that flight was not very big because I didn't close it's an open track, but there is still a little triangle. But the 6-leg distance, these are the legs. So the system, I'll just stop it so I can show this a little better. So the system calculated what those 6 legs are. So if I hover over the legs, so here's the first leg, and that was 17.8 miles, and you can see it highlighted on the map as well as in the barogram what that leg was. So here's the second leg, that was about 183 miles, and I spent about 25% circling at average climb 6.1 knots, and average glide was 1/47. You can see that in this little table as well as on the barogram. So I can sort of, so here is next leg and then next leg, next leg, and then finally my little leg, made it 30 miles an hour just trying to sketch out. As far as these two views, you can also switch them, so I can switch between big map and little map, so I can put the three-dimensional map here, and so if I just wanted to have more immersive experience. Let me switch back to this God view, so actually I'll just reset it. So you can sort of get a pretty good idea what's happening. This is a big new thing that it allows you to upload your IGC files after the fact, and really, in a sense, your low-level, crappy, low-resolution spot trace, you turn it into high resolution, and you do all of this analysis. So I'll stop this, but stop the playback and talk for a second. Why do we have to have this distinction between low-resolution tracks and high-resolution tracks? Why do we have to upload IGC files after the fact, after we fly? Why don't we actually just stream that data as we are flying? There is another thing. So there is a little mobile application that's a sort of companion that goes along with this, which is called GlideTrack, which runs on iPhones and Android phones and so on, and little devices. And it's a public API, that I'm making that API public, so anyone, like other people that make flight devices and different flight software, they can integrate this, and they can integrate with GlidePort. But basically, it's just a little recorder that you run on your phone, and in addition to recording, it sends data down to the ground when it can. Now, this is running over a mobile network, so when it can is important thing, because you don't have cell phone coverage all the time. But it's robust, so it's fault tolerant. So when it gets within the range, it will do it. I just ran a simulation of that application running, pretending it's flying another flight right now. So think of, I'm flying now, I have this in my glider, and the data is streaming, and I'm flying out of Boulder. So I'm just going to jump to Boulder today, to the latest data, and so here is actually, I'll switch the view so I can look at the map here. So here is the flight that's in progress. This is IGC. You can see that barogram is incomplete. Again, I just came out of thermal. You can sort of see that, and this is where I am. This is what it looks really, except I'm not flying. And I can also click, I can put my cursor back in time. And so, for example, if I put cursor, let's just put it here, and I can play back. So I'm playing back, so maybe, this was half an hour ago. So I'm starting from half an hour ago, looking at, and so I'm flying, here's the continental divide, you can sort of see it. And so you can sort of see what the track does. I hopped over the divide, so here's Lake Granby. So this was about half an hour ago, but I'm playing back at 30x the speed. So eventually it's going to run out of data because it's going to get to the now moment. Here's that thermal, and as it got to that thermal, actually you see it sort of is not going that fast anymore. It's basically running at 1x speed, and this time code indicator switched to green to indicate, that's the indication that it's running at 1x speed. So now it's actually showing me the data live as it is coming. Actually there is little lag time, and in this case it's configured to be 5 minutes. So I'm seeing data as of 5 minutes ago. And as the new data comes in, again, so let's move this. So it will all get updated. And so I'm seeing my instrument as of 5 minutes ago, so I'm thermaling. You can see my indicated airspeed is on the order of 60 knots. Really means I have water on board. And my climb in that thermal was about 7 knots or so, climbed to about 15.5. So this was actually a tough day. The cloud bases were pretty low, so it was hard to go places. Oh, so while I was talking, you see that there is more track now. It just came in. So there was another little segment that just filled in. And we're just continuing. And up to this point, I made 236 miles at 72 miles an hour. So this is basically now live flight following with high quality flight analysis. And you get all the performance whatever the person is doing. So this is one track, but it can be any number of tracks. So again, on that day, I was the only one flying out of Boulder. So let me just jump to another day where there were multiple people flying. We'll just leave this alone. So here is another day, which was a pretty good day, and lots of people flew out of Boulder. And I did this triangle, Doug Weibel did this, Bob Caldwell, you went south to Sangres, Bob Ferris did a similar route. I think Tom did a pretty good flight as well in Sierra Gulf. That's Bob, so Tom is flying right behind Bob, and they're about the same altitude. And I can click on Tom, so now I get Tom's point of view. So Bob is a little ahead and making distance. So now I'm looking at Bob, and he made 357 miles for the day. Bob did 330-ish miles for the flight. Another thing that's new in this version is there is this edit function. So you can edit your flight. So you can put your comments and do things like that. I'll pause this. You can also click on this button here, which allows you to basically like or dislike even flights and comment on the flights. And so you can see great flight, Bob. And so I can post that comment, and I can give thumbs up. So then basically in this button you get summary. So there are 3 comments, there is 1 thumbs up. And talk about the mobile application for a second. So my concern with mobile, and we fly in mountains, so our coverage, we don't expect to get a good coverage. So I did a bit of testing to see how good that really is. So few flights that I did, I took it along. So here is a flight that I did that was April 10th. So, and just click. So Bob Ferris flew on that day, and I have actually a number of tracks. It's the same track, but just from different loggers, and as I was comparing it. So this was actually a pretty nice wave day. And staying really at 18,000 for a good part of really when Abin Boulder. So from about here to here, it was all 18,000, and then it's lower here. What these little circles indicate, they are actually places where my cell phone had good enough coverage that it was able to send data down. which is actually surprising that at those altitudes, you see, I mean, there are some gaps. So, for example, this fix, this was like 11:41, the next one was 11:48, so there were 7 minutes here. Let me actually put my cursor, and I was at 16,000 here. So there were 7 minutes here that didn't have coverage, and it didn't have coverage right here, obviously, when I was right over the divide at 18,000, but surprisingly, it did have coverage in many other places. And remember, like spot fixes, they're 10 minutes apart, and you get just that one point. And here, when I get this fix, it's not a fix, it's all the data up to that point, this high resolution data. So, and especially if you look in this area, you see a lot of fixes. So this was actually a very nice surprise. Here is another flight. This was, I think, yeah, from the last weekend. So this is again, this is even better. I was more out of the mountains, but it still was pretty high altitudes. Here is Colin's flight on that day. And also, I took his IGC and just uploaded it. And here is Bob's flight on the day. And again, you can just zoom and see who was there, who was doing what, and so on. So yeah, so it really looks surprisingly good that there is as much coverage and as high altitude as there is. That was one of my concerns. It's really can mobile work for this type of application? And if it can work for us, it's going to work for most of the places in the US. Yeah, and that's the other capability of this little software. You can also send messages. So, and if you send a message, you see it here in the GlidePort.
You put a phenomenal amount of thought into this. I mean, it's really great.
Colin? Yeah, I got to say, this is just stunning. Okay, that's what might be my comment. But does the mobile software run on both iOS devices and Java-based Android devices, or is it limited now to one platform?
Yeah, what I'm doing with this software, I'm actually releasing it as source code, and I'm making it be the reference implementation. This is the big picture. This is how the system works. So there is GlidePort out in the cloud. So then you have spot satellite devices, the data goes, let me actually turn this off. The data goes to the ground, to GlidePort, and that's what you saw in the previous version. And spot is not great. There are with the new spot you can get 5-minute fixes. There is no altitude data. It's only one way. There is a lot of lag time with spot, and it's actually pretty bad. On the other side, you have all the people watching it, spectators, your crews, other pilots, whoever. And so they're watching you in real time, and they can or they can see historical data, as I was saying. InReach is an improvement over Spot. It's basically the same concept. You have a device, satellite device. In this case, it uses Iridium satellite network. Signal goes down, comes down to the ground, somehow eventually finds its way into GlidePort. It's a better spot. So you can have, it does have altitude data. You can have shorter fixes, up to a minute. It is expensive. It's as much as twice as expensive as Spot, and it does have other issues, and so I'm not a huge fan of it. Another approach is actually because InReach is basically an Iridium modem, really, in the device itself, and it does have Bluetooth interface. So you can use InReach and write little software that talks over Bluetooth to InReach, and just use that InReach device as a modem to send data. And in that case, you can actually send high-resolution data. Except the problem with that is that it's gets really expensive because you are sending a lot of data through very expensive transmission way of transmitting it. So you can have less than 1 minute fixes. It's if you are only going to send like 1 minute fixes, it's great. I mean, you can compress data and cost-wise, it's good. Or another way is you can possibly have a custom Iridium device. It doesn't have to be InReach. It's easy enough nowadays to buy Iridium chip. You put your own microcontroller and you make your own device to basically build a better, cheaper InReach. And then finally, this is this glide track approach, which is you have your smartphone, which you have anyways, you have your cell phone network, which you are paying anyways, and let's just use that and really allow for this fault tolerance, and because knowing sometimes you're not going to get those fixes. And so using that, because that's a really cheap way of transmitting data, you can have high resolution, very low cost, but again, coverage is the problem. And you can also do IGC upload directly. So even if you don't have a tracking device, you just go out and fly. After the flight, you pull your IGC file, you go to the website, same way you would do it with OLC, you upload it, and there is your track. You analyze it, you see it in the context of the day, alongside with what other pilots have done out of that GlidePort. You can compare your performance. You can turn on weather overlays, correlate it to what weather it was doing in that day, and so on. What I was showing today actually requires you to log in. Again, when you want to start uploading your flights, the system needs to know who you are. The these two methods that are in gray, this is really what the future is. This is the future is high resolution data in near real time, or as close to real time as we can get. There is API in the GlidePort software that's public, so everyone can actually talk to it and submit it. So as I said, the software, the mobile software that I built, it's just a reference software. It's just to let people get going, to make it easy for them to get started and be able to send data. Yeah, the API is very easy and it's very clean. It's made to be as minimal as possible and as simple as possible. And the reference application, it is actually implemented in JavaScript, so it's cross-platform, so I intentionally made it so you can pretty much run it on anything, and it's clean enough to do it that way, so you can really see what's happening and how to implement things.
You have to run it inside a browser?
So you can run it inside the browser, but the way it's running on iPhone and on Android, it's running as native. Let me just go back into this social thing. One thing that you can also do is apart from putting comments, and you cannot actually like or dislike your own flight, so that's why this is disabled. But you can also follow a pilot, so you can go and follow your buddy. So when you do that, when your buddy flies from on that day, regardless of what device he has, whether he has a mobile device or a satellite tracker, when he turns that on and the track gets down to GlidePort, you basically get an email notification with the handy-dandy link that you just click on, and then you see a map with that person, and you can actually then click on him, and you're basically in cockpit with him flying. And this is open to everyone, and everyone can go and register, and yeah, my intent is to make it as open and as accessible as possible. Yeah, and for example, here is the little download button. So if I wanted to download this IGC file, if I wanted to have that IGC file, you can just click here, except I don't know why you would want an IGC file when you can actually look at it here in a much nicer way than any place else. So when you go and start using it, I just wanted to point one important thing that actually I took time to get done. If you go into info and click help, you get a very nice help, and you can, it's a dynamic help, so you can, as you read it, if I wanted to learn about, oh, what does this thing do? Well, this is a barogram. So you just put your cursor here, and it tells you what it does, and it tells you all the shortcuts that you can have. Or say, oh, tell me about the airspeed indicator, what things mean there, and or tell me about this. So there is actually pretty good documentation to get you started. This is a World Gliding Championship. So here is my track. So it's actually, these are all the tracks. So this is the first contest day out of Uvalde. Oh, let me point to one more thing. So you see that a lot of tracks that now I'm looking at are in light blue. That's because I uploaded those tracks as myself, as IGC tracks, and those are really my own private tracks. You cannot, the system doesn't, this is by design, the system doesn't allow you to upload other people's flights. You can upload your own flights and they are by default public, or you can make them private if you wish to do so. You really get a lot of insight using this tool. Okay, I'll stop this and I'll just do one last thing, which is just jump back. So here is this flight that I'm flying now. It's still flying. It's coming in. So here I made a little more progress now. Again, this is running at real time. So I'm just in. When we left off, I was about here. I think a little past. No, I was around Granby. So now I'm kind of made it south and halfway to South Park, and now I'm heading back again. Switch to God view or pilot's view. Just few last comments. So there is a lot of technology in all of this, and this is one application, for soaring. It's highly the user interface is highly optimized for soaring, but this is also quite applicable to many different areas of activities. I mean, one way to characterize it, this first step, it's really America's Cup for gliding on the cheap.
It's a great learning tool.
And
For somebody who doesn't have much cross-country experience, it's a wonderful learning tool.
Yeah.
I mean, way to go.